basic of networking, which is gonna be, one of the key fundamental of enhancing your skill towards cybersecurity. So you must be knowing like what is networking, right? So what exactly is networking and how it is crucial in cybersecurity. So very first thing you need to understand about networking is what is networking, okay, and how it works, and what are the different things which you need to know, okay. So it's very simple that networking is how computers talks to each other, okay. So if you take an
Yeah.
example here, so you must be using your the system. So let's say you're using a system, let's say in your system you're using Google Chrome, okay. So you're using a Google Chrome, and you're trying to extract or fetch some information from the internet to see what I mean. Let's take an example of what is cybersecurity. So now what happens is, your browser will send a request to the destination server. Okay, so it can be Google server only. It sends a request, and in return, what it does it comes back with the response. Okay,
Mhm.
so we say it a three-way handshake. So we say it a three-way handshake. Okay, which is very important to understand three-way handshake. So
Mm.
let me just share my screen, I mean the other whiteboard, so that I can explain you the other way. Let me share that. So please let me know once the whiteboard is visible. Is it visible?
Yeah.
Okay, so let's say this is your system. So this is your system. Okay, and let's say this is the target. I mean, it can be a server which you are trying to reach. It can be any server. So when you open up your browser and then type down www.google.com, okay, so let's say google.com or facebook.com or any site which you want to visit. So what happens is, the very first thing is, your system or your computer sends a request to the server. Okay, so this is basically called yeah, your computer sends a request, and from the other computer, that is your server, you get a response. And from your computer, again, there will be a response which goes to the server. This is called three-way handshake. Okay, this is called three-way handshake. So first, your computer will send a request. Okay, and then from the server will send you the response. And again, from your computer, it will send a response stating that, I mean, a kind of confirmation stating that whatever I was trying to get, I got it. So this is called three-way handshake. Now, another important thing which you need to understand is different types of flag used in this entire communication. So first flag which is used is sync. Next is your ACK. Third
Sorry,
is your,
what do you mean by flag?
I'll come to that also. Okay, I'll come
Mm.
to that. Okay. All right, now coming to flag. Now, so usually, in a TCP IP model, which is transmission control protocol, an internet protocol model, there are flags which is used. Okay, so there are flags which is used to build up a communication. So when we say flag, there are 6 different types of flag which is used in a TCP IP model. So TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. And there is another, model which is known as UDP, which stands for User Datagram Protocol. So there are 2 different types of protocol. I'll just write it here. One is your TCP, and the other is UDP. So TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. So when a TCP communication is established, as I said that there are two different types of protocol, but when a TCP communication is established, there are 6 different flags which comes into picture. Not every flag will come into picture, but out of this 6 flag, one of or two of them will come into picture when there is a transmission control protocol communication. So now we have to segregate or identify the differences between TCP and UDP before we jump into flag. So TCP is a transmission control protocol. UDP is a user datagram protocol. Now, TCP is reliable. Okay, TCP is completely reliable connection, whereas UDP is not reliable. TCP will guarantees the delivery of the packet, whereas UDP will not guarantee the delivery of the packet. You getting my point?
Yeah.
So let's segregate in, or let's try to understand it in a different way. So for an example, let's say, you're sending a mail. Okay, so when you're sending a mail, that means a reliable connection has to be established because those mails are very important, right? And the good thing about TCP is TCP gives you, the acknowledgement. I mean, the confirmation that your delivery, I mean, your packet, I would say packet, or your request has been delivered to the so and so server completely. So it gives you the acknowledgement also. Whereas UDP does not gives you an acknowledgement because it's not a reliable connection. So when you're sending a mail, I mean, a mail has to have, a reliable connection. Okay, a mail has to have a reliable connection because you need to know that whether the mail is transferred or it has been sent to the destination, recipient or not. So when you're sending a mail, that means by default, TCP will come into play. When you are, watching or viewing some live broadcast, or let's say we are communicating, via Zoom. So that means UDP is coming into picture because comparatively to TCP, UDP is fast. It is much faster than TCP. So that means UDP, whenever there is a scenario or whenever there is a case where we need a faster connection, that means UDP come into picture. Got it?
Yeah.
So when you're writing www.google.com, that means TCP will come into picture. But when you're writing youtube.com and then you start trying to see YouTube videos, that means UDP will come into picture because UDP needs a faster connection. So if the packet get lost also, if the packet drops also, it doesn't matter to UDP because it just focus on the speed. Okay.
Okay.
Any question here? All right. So now there are 6 different types of flag. As I've mentioned, I will explain you using this diagram so that you'll have a very clear understanding. And if you have any question, you can just let me know about this flags. Where is that? Okay. Yeah, please let me know once it is visible.
Yeah.
Okay. So as I mentioned that there are 6 different types of TCP flags. Okay, one is your FIN flag, the other is push, the third one is urgent, and then synchronization, reset, and acknowledgement. So let us understand this flag one by one. What is synchronization? So this flag represent the establishment of a new connection between two hosts. So whenever you're trying to initiate a connection, okay, so whenever you're trying to initiate a connection or trying to create a new connection, that means synchronization flag will come into picture. So, in a nutshell, you can understand this, that synchronization flag is responsible for creating a new connection. Okay. Understood?
Yes.
Then comes your FIN flag. So this flag represent that there will be no more transmission of packet from one host to another, as the connection is terminated gracefully after completion of the transmission. So, fin flag is like, for an example, let's say you open up a facebook.com. Okay. And
Mm.
after opening up a facebook.com, now you're viewing your post. So after viewing your post, you felt that, okay, I need to, stop this session. So what you will do is you will log out from that account, right? So once you log out, that means your connection or your connection or that establishment of a connection has been, is terminated. So that means there
Yeah.
will be no more data transfer between your computer and the Facebook server.
Okay.
So whenever you are terminating, your connection, or let's say if your internet gets dropped, or let's say if you are logging out, that means a fin flag will come into picture where fin flag will terminate your connection. The fin flag will terminate connection between two hosts. That means you and Facebook server. Is that clear?
Yes.
Any questions?
No, not yet. No.
Okay. Next is your push flag. So these flag represents buffer data is pushed by the sender's end and the receivers should be informed about the buffer data. Now, see, when a computer is communicating, when two computers are communicating, there are different, packets. We say it packets. Okay, so there are different packets. So there are different packets which is segregated in chunks. We say chunks of data. So for an example, let's say I'm sending you a file. Okay, I'm sending a file. So let's say it can be a doc file, it can be a photo, or it can be anything. So when I'm sending you that file, the file does not go at once. Okay. Instead, it is divided into chunks. That small pieces will go first. And after that, when your download is completed, then download is completed, then, it gets reassembled and then that is provided to you. So if you take an example also, let's say you are downloading a movie, or let's say you're downloading a game. So if the game is of 15 GB, or if that file is of 1 GB, that 1 GB will not come into, it will not get downloaded automatically. Completely 1 GB, no, it will not happen. So what it will happen is it will break into chunks. That means you will be getting small bits of packet or chunk from the from wherever you have requested it. So once the entire files, or once the entire files or the chunk files get downloaded, then it is reassembled back into its sequence, and then you get the complete data. Okay. So now, when you are downloading anything from the internet, so your computer has a capacity of accepting those traffic. Now, by default, in a memory, what happens is when you are downloading any stuff, so there are certain buffer data on their side. So let's say they have they will send you 10 files, but in buffer memory, they will keep 5 files. So as soon as that 10 file, gets to your computer, that 5 buffer data will come, will come back in the start, a frame, and then again 5, this chunk of data will be in buffer memory. So it does not goes at once. There are certain buffer memory which is kept. There are certain buffer, files which are kept. Now, sometimes it is required to send those buffer data directly. Let's say I don't want to keep any buffer data. If I'm sending you any file to you, I don't want to keep any buffer data. I want to send everything at once. So I can use this flag. Okay, I can manually use this flag to send whatever is there in the buffer memory also to you at once. Okay. Got it?
Yeah.
I'll explain you when it comes to the header. So you just need to understand a very basic here. So that means when it comes to push, there are certain buffer data in the memory. If you want to send that buffer data, okay, so you have to use a push flag, and the push flag will allow you to send all that buffer data at once. Okay.
Okay.
Next comes your urge. Now, at times there are files which needs to be sent urgently, or
Yes.
there are packets which needs to be sent urgently. So at that point of time, what you need to do is you need to set urgent flag, and what urgent flag will do is urgent flag will send the data immediately. So that will be on a priority basis. Okay.
Yeah.
Next is your acknowledgement. So the acknowledgement is whenever, so let's say I am sending you a file. Now you have received that file. Now after receiving that file, I should get an acknowledgement from your computer stating that whatever you have sent, it has been delivered successfully and I have got the file. So your computer will send me an acknowledgement stating that all the files has been transferred successfully. There is no other file which needs to transfer. So that is what acknowledgement is. So acknowledgement is basically acknowledging the complete transfer of the packet.
Okay.
Then the other one is reset. So this flag is used to end the connection, which means there will be no more transmission between the host. So at times, now see, it works as the reset button, the reset. So what happens is if you want to reset anything, let's say if you're sending a file and you feel that there is some issues with the internet, or there is some issue with your computer, right? Then you can always
Mhm.
opt for reset. So what reset will do is reset will will close all other process, and then it will start transferring the file from the beginning.
Okay.
Okay. So now, so this is like you might have some question here that where this will come into picture. So just you need to understand these are the these are the 6 different flags which is used. Okay, these are the 6 different flags, and I'll correlate it when we will do it practically. Okay, but please
Okay.
make a but please make a note of this. You don't have to write everything. Just write synchronization, fin, push, urge, ACK, and RST. 6
Okay.
different flags. Yeah, 6 flags.
Okay.
Okay, now this is also very important to see TCP headers. Now, when there is a transmission of packets, now each packet will have its header. As I said that if you're sending 1 gigabyte of data to someone else, or if you're downloading 1 gigabyte of data, that means it does not goes at once. It goes in a chunks.
Yeah.
So that chunks will have this header. So the first thing what your header will have is the source port. That means from where the data is originated. It will have the IP address from where the data is originated, and it will have a destination port where it has to go. Other thing is it will have a sequence number. So what the sequence number is? So sequence number is needed when all the data has to reassemble. Because now if you're sending a data in a chunks, that means it will have a sequence number. So that sequence number later on will be used to reassemble everything in a sequence. So let's say I'm sending you 10 packets. Okay, so let's say I'm sending you let's say 10 different packets, or let's say okay, let's say I am I'm sending you computer with a disassemble format. Okay, so now later on, what you will do is you'll try to assemble it, right? So when you assemble it, you have to know which will come at the first, which will come at the second, and which will come at the third. Okay, so it's reassembling. So when you don't know that which needs to be come at first, which needs to come at second, that means you will lose it. You will be completely lost. So in the same
Yeah.
way, when you download anything, okay, as I said that it does not get downloaded on your system at once. There has to be a transfer of the packet. So that packet will contain the sequence number. So on basis of that sequence number, later on that packet will be reassembled. Okay.
Yeah.
And then you have this acknowledgement number. So acknowledgement number is once your data is transferred, once this header is transferred, it will have an acknowledgement number stating that this has been successfully transferred to so and so computer
Oh.
or so and so IP address.
Oh.
Okay. So next thing is your header length. So every header will have its own length. So usually it is of 4 bits. Okay, so every header length is of 4 bits. So it has to accommodate everything here into 4 bits. And this is a reserve space. So sometimes, your packet can be larger, or sometimes it may contain more information. So at that point of time, this reserve bits of 6 bits will be used on that cases. Okay. And if you can see here, there are different flags. So now, I mean, all the flags will not come into picture for the packet, but yes, there are flags like, let's say, synchronization. Whenever you're trying to initiate a connection between two computers, that means the synchronization packet goes to the destination server. So that packet will consist of sync flag. Okay, that packet will consist of sync flag, which goes to the destination server, asking for initiating a connection. Then your computer, then the destination computer will send back with synchronization plus acknowledgement, which I will discuss later, three-way handshake. Okay, so please remember that this is for what? This is for your flags. Then comes your window size. So window size is basically, it's a capacity of handling the traffic. So that is mentioned here. So that's just a size. Then comes your checksum. So checksum is basically checking the integrity of this, header. So you never know, like, what the malicious attacker can do is, some attacker, what they can do is they can, inject some, some payloads on this header, or they can inject some query or command in this header. So for that reason, whenever your computer is whenever your computer is transferring a packet to the destination computer, that means there is some sort of integrity check, just to make sure the packet which has come to your computer is the right one, and it has not been altered from any sources. So when my computer is trying to send you a file, there is a value which is created. There is a checksum value which is created. Okay, and it cannot be changed. I think, yeah, it cannot be changed. So when your computer receives the packet, there will be another checksum value which is already defined. So your computer will try to match that value, and once it is matched, and if your computer feels, and if your computer validates that it is the right one, then only your computer will accept that packet, or else it will drop that packet, assuming that this is a suspicious packet which has come from unknown source. Any questions here?
No, I want you to. Okay, no, I get it.
Okay. Then comes your urgent pointer. So urgent pointer is basically, it's pointing towards urgent packet. Now, as I said that, there are 100, thousand and thousands of packet when you try to download any stuff from the internet. Now, whichever packet seems to be urgent, the pointer will point that packet, and it will be downloaded to your computer, in a priority basis. So this is urgent packet. Okay, these are the bytes which will have different information, and this is data which is optional. So this is complete. Excuse me. This is complete TCP header. Okay.
Repeat this urgent point again, please.
Which one? This one?
Yeah, the urgent pointer.
Yeah, urgent pointer is basically pointing towards urgent packet which needs to be sent in a priority basis.
Okay.
Okay, so there can be so many different data or packets which has to be sent urgently. So this one will point out to the packet, okay, this is the packet number which has to be sent urgently. Okay, so this was TCP header. And as I said that there is only two headers, so there are only two protocol which will come into picture. One is TCP header and the other is UDP header. Okay, so you can see that TCP header consists of so many information, because TCP is a transmission control protocol, and it's a reliable protocol to use because it guarantees the delivery of the packet. There are so many different informations which TCP has. But whereas UDP will have only this information. One is your source port, the other is your destination port, then the length of the total header, and then the checksum value. So there is no flags, nothing. Okay. So you can, yeah. The source port, that means
IP.
from where the packet is initiated, and the destination port where the packet has to go. Okay.
Yes.
Any questions?
No.
All right. So now coming to three-way handshake. So let's say this is your client computer and this is the server computer. So client means you, and it can be any server. Now you want to initiate a connection. So if you write down www.google.com, so what happens is there is a packet which goes with synchronization flag on it. It goes to the server. Okay. Now what server will do is server will send back you synchronization plus acknowledgement. That means you tried to initiate a connection between this client and server. The server accepted it, and then the server is sending a response. Okay, fine. You wanted to initiate a connection, or you wanted to access my resource. I'm giving you permission to access my resource. So again, the server is sending synchronization plus acknowledgement. That means it is giving acknowledgement that yes, whatever you're trying to do, I have given you the permission. So once a client receives what he is looking for or what it is looking for, so let's say you are looking for google.com. So once you get the Google page, your client computer, I mean your computer, will send acknowledgement to server stating that whatever I was trying to access, I got it. Thank you so much. So this is how a three-way handshake is established.
Okay.
Okay.
Yes.
So any questions here? Please let me know any questions you have.
Right now, I don't have any question.
Okay. Okay. Fine. So let me share my screen again. All right. So you are able to see my screen, right?
Yes.
Okay. Now see, when a computer is communicating with each other, okay, so there has to be a path to communicate. So there is basically a path to communicate. I mean, we can say a gate to communicate, because all the traffic cannot be, cannot be passed from a same gate, I would say. It has to have a different gate, or else there will be congestion of traffic. So,
Yes.
So there will be congestion of traffic. So every traffic or every protocol has its own, port number. So let's start from, very simple port, which is FTP. So basically FTP is used for file transfer. So let's say, you are in a different part of the world. I'm in a different part of the world. Now, let's say I have a server. Okay. I want you to access that server, and I want you to update the server from your location. So what you will do, you'll transfer a file. You need to transfer some of the files. So at that point of time, you will use FTP to transfer a file. So which is known as file transfer protocol. So FTP stands for file transfer protocol. Okay. So this protocol uses port number 20 and 21. So before that, let me also tell you that there are port which starts from 65,535 ports. I mean, there are ports start from 0 to 65,535 ports.
0 to 65,500.
Yeah, 65,535 ports. Sorry. Yeah, 65,535 ports.